Math 1, Unit 2.2, Practice. Alright, today we're going to talk about patterns and linear functions. So let's first talk about what a function is. A function, and I like to draw my little function machine here. A function is a machine that you put things in and it will kick things out here. Okay, that's our little function machine. We put x's into the function and out come y values. Alright? Every x value you put in can only have one y value associated with it. If you put a 5 in and a 7 comes out, every time you put a 5 in, a 7 is going to come out. Okay? If you put in a 5 and a 7 comes out, and then you put in a 5 again and a -3 comes out, your machine is broken. It's not a function. All right? So a function, we could say, I'll write this kind of small over here, every x value is only associated with one y value. Every x value can only be associated with one y value. Okay, you want to go get a drink? Yeah, why don't you go get some water? Alright, so if I put in a 5, I expect a 7 to come out every time. Alright? Now, if I put in a 5 and a 7 comes out, and I put in a 6 and a 7 comes out, and I put in an 8 and a 7 comes out, that's okay. Alright? A y value can be associated with more than one x values, but an x value can only be associated with one y value. Okay? Alright, so that's a function, and we are strictly talking about functions here. So what they want us to do here is, for the diagram below, find the relationship between the number of shapes and the perimeter of the figure they form. Represent this relationship using a table, words, an equation, and a graph. Alright, so we're going to start out with a table, and it's pretty simple. Our x value is going to equal the boxes, the number of boxes, 1 box, 2 box, 3 boxes, and the y value is going to represent the perimeter. So this is what we call a T-chart, and we always like to use the x and y because, as hopefully you remember, this is the x-axis, and this right here is your y-axis. Alright, am I going too fast? Alright, so this is pretty straightforward. We have one box, so we're going to put that here for x. And then we have 2, 4, 6, a perimeter of 6. And over here now we have 2 boxes, so we'll say 2x. And our perimeter is 2, 4, 6, 8. And finally 3 boxes. And we have a perimeter of 2, 4, 6, 8, 10. Okay. Yes. Sure, why not? Alright, so we start off with a perimeter of 8. You'll notice we have 2, 4, 2, 4, 2, 4 on every one of these figures, right? And what changes is, with 1 box there's 2, with 2 boxes there's 4, and with 3 boxes there's 6, right? So what we can say is, if y is the perimeter, it is equal to 2x plus 4. The 4 represents the unchanging part of the figure. In every figure, the top and bottom add up to 4, don't they? 4, 4, 4. So we represent that out here. Okay, that's kind of the unchanging part of it, the constant. But as your boxes increase or your x increases, the side values increase by 2, right? 1 times 2 is 2, 2 times 2 is 2, 2 times 2 is 4, and 2 times 3 is 6, isn't it? So we can represent that by the 2 times x. 1x, 1 times 2 is 2, 2 times 2 is 4, and 3 times 2 is 6, isn't it? So if you look, 1 times 2 is 2, plus 4 is 6. 2 times 2 is 4, plus 4 is 8. And 3 times 2 is 6, and 6 plus 4 is 10. So that's where we get our equation. All right? Now, our written part, I'm going to make it pretty easy for you. We're not going to concern ourselves so much. Anybody remember what this is called?
The y-intercept?
The y-intercept, okay? And so what we can say is when x is 0, y is going to equal 4. So if we were here, y would be 4. Okay, but in this case, it doesn't make any sense to have 0 boxes and have a perimeter, does it? So this one really doesn't really mean anything at y equals 0 or at x equals 0. But we can graph it at when x is 1, when there's one box, we know the perimeter is 6. So 2, 4, 6. Okay? When the boxes are 2, we know the perimeter is 8. And finally, when there are 3 boxes, we know the perimeter is 10. So hopefully what you can see as x increases by 1, y increases by 2, doesn't it? So that's what we're going to write for our words. As x increases by 1, y will increase by 2. This basically describes something you guys have heard last year, rate of change. You guys remember that? Rate of change, also known as slope. Good job. Slope. Okay? The rate of change and slope are interchangeable. What we can see here as x increases by 1, our y values are increasing by 2. We call that rate of change. Okay? So let's see what we got. We represented it in a table. We represented it by words. We represented it as an equation and as a graph. Okay? So before we go on, let's talk a little bit about the graph. So this is our x-axis. You remember here where the x and the y-axis intersect. What do we call that? The origin. The origin. Think about, you might go, if you go on a trip, they might say, where are you from? Where do you originate from? Where are you originally from? When you move, you might say, oh, where are you originally from? Origin, originally. Okay? The point of origin is where you start. Where do you start? I'm originally from Anaheim, California. I bet a good chunk of you guys are originally from Fresno. Raise your hand if you're originally from Fresno. Okay, that's where your life started. When we talk about graphing equations, we always start at the origin when we're graphing or plotting a point. Okay? So when I plotted the point 1, 6, I ran to 1 and I jumped to 6. Okay, you can always have to run before you can jump. All right, and this is your x-axis. We have 3 other names for the x-axis. Anybody remember any of them?
Wait, what?
We have 3 other names for the x-axis. I'll give you one. One is the independent variable. We use this a lot when we're doing word problems or if I do my little quotes here, real world problems. The independent variable is the one that really is in it under its own control. A lot of times, independent variable is time. Nobody controls time, right? So time would be your independent variable because we have no control over it. But what happens over a course of time is the y value. We call that dependent variable. Okay? In your home, your parents are the independent variable and you guys are the dependent variable. Hey Mom, can I go to the movies? Well, that depends on whether you cleaned your room or not. Mom, can I go to my friend's house? That depends. Did you do your homework? Or Mom, can I go to the mall? Well, that depends if I have any money in my wallet, right? So everything you want to do depends on your parents' mood, right? Okay, so they are the independent variable, you are the dependent variable. Okay? The next one we have is input. And over here on the y-axis is the output. If you remember my little function machine up here, we put the x's in and the y's came out. In this case, we put in a 1 and out came a 6. We put in a 2 and out came an 8. We put in a 3 and out came a 10. Yes? On this one, if we put in a 5, well, 5 times 2 is 10, plus 4 is 14. Okay? And our last one we have is domain. Domain, and the related one over here is range. We will talk about domain and range quite a bit this year. Have you guys heard domain and range before? Yeah? Okay. Domain are all of the possible x values of your function. Range are all of the related y values of that function. Okay? All right, let's go on to number 2, unless there's any questions. By the way, all of those words pretty much are over there on our word wall over there. So you can always look over there if you need to remember one of those words. All right. For each table, determine whether the relationship is a function. Then represent the relationship using words, an equation, and a graph. All right, so if you remember that a function, every x value can only be related to one y value. Is that correct? All right, so all we have to really do is make sure that our x values don't repeat. Okay? If our x values don't repeat, then we've most likely got a function. So if we hear 0, 1, 2, 3, all of my x values are different. They all increasing by 1. As I look here, plus 1, and plus 1. 0 plus 1, 1 plus 1, 2 plus 1. Okay, and now we can look at our y values and go 2 plus 1 plus 1 plus 1. So we have a function, and you notice my x's are increasing by 1 and my y's are increasing by 1. Okay? So this is a constant rate of change. A constant rate of change. Any questions? All right, so why don't you go ahead and graph these points on your graph right here.
Isaac and Gracie.
Isaac. Okay, Isaac and Gracie. Here's Gracie. Isaac. Will you hand that to Isaac, please? Thank you. All right, so you should have got 0, 2, So that's what we call the y-intercept. When x is 0, y is 2. This is your y-intercept. Intercept is like, think about if any of you guys watch football, an interception. It's where the defensive player intercepts the path of the ball. An interception or intercept. It's where your graph will cross the y-axis, the y-intercept. Then we have 1, 3, and we have 2, 4, and we have 3, 5. And you can see that this is a linear equation because all of our points are in a line. A linear equation has a constant rate of change, meaning the rate of change is unchanging, constant. It's the same. All right, so let's see what we got here. We've got our graph done. We're kind of working backwards here. So our y values, remember, depend on our x values, don't they? But when x is 0, whatever we multiply times 0 is going to be 0, right? But when x is 0, we still have a 2 out here, don't we? So when x is 0, y is 2. Well, let's see now. What about when x is 1?
X.
It equals 1, doesn't it? So isn't it basically 1 times x plus 2? So when x is 1, 1 times 1 is 1, and 1 plus 2 is 3. Right there. Let's see if it holds up. Y equals 1x plus 2, and let's plug in, I meant to plug that in there, y equals 1. So what's 2 times 1? Plus 2 is? So when x is 2, y is 4, and that's true. Now let's try y equals 1 times 3 plus 2. Well, 3 times 1 is 3, plus 2 is 5. So when x is 3, y is 5. So it holds up. So there's our equation right here. Do we need the 1 out in front of the x? No. But when this number out in front of the x is what we call our rate of change or slope. Rate of change is 1, or we could write it as 1 over 1. So as x increases by 1, y increases by 1. That's our rate of change. And this is our y-intercept, okay, which is where the graph crosses the y-axis. How are we doing? Okay, words. We really, all I want you to do is get in the habit of talking about the rate of change. So I'm going to say as x, and I'm going to make some shorthand here, increases by 1, y increases by 1. Nope, not in this case. X increases by 1, y is increasing by 1. All right, how are we doing on that? Easy enough? Okay, let's turn the page over. I'm going to leave number 3 for you to do in a minute. Let's do number 4 together. Basically the same thing. All right. So, for each table, identify the dependent and independent variables, then describe the relationship using words, equations, and graphs. All right, so our x's are always going to be our independent variable. And our y's will always be our dependent. So we could, I guess we could write independent and write 0, 1, 2, and 3. And then write dependent is -2, -1, 0, and 1. Independent variable is always your x values. Dependent variable will always be your y values. Okay? Describe the relationship using words. And again, let's go with something simple. as x increases by, how is x increasing here each time?
By 1.
Okay, so as x increases, we can use some shorthand if you're comfortable with that. As x increases by 1, y, well, does it increase or decrease? Let's see. It's increasing, and what is it increasing by? 1, okay. It increases by 1. All right, let's graph it now. So at 0, we have -2, so it's kind of a small graph, so you got to be careful. Okay, remember that's what we call our y-intercept. When x is 1, y is -1. And let's see, when x is 2, y is 0. And when x is 3, y is 1. So we definitely have a linear equation here, don't we? All right, so let's write out our equation. Hopefully you remember that our linear equations, we can write them in what we call slope-intercept form. You guys remember talking about that last year?
Yeah.
Slope-intercept form, and that's always y equals m, which is our slope or rate of change, times x plus b, our y-intercept. Okay? So let's write this over here. Let's write it up here. So m equals slope or rate of change. I'm sorry, I wrote that kind of small too. So that's m equals slope or rate of change. It looks like damage, but it's change. Rate of change. change. Okay, and b is our y-intercept. B is our y-intercept. And remember, that's when I'm going to put x equals 0. So let's see, where does x equal 0? What is y when x equals 0? It's -2, isn't it? Can you guys see that down here? So if we write our equation, we know that this is going to be -2. We could put plus -2 or just -2. Our linear equations will always have a y in them. And now m is our slope, which rate of change. What's our rate of change here?
1.
As x increases by 1, y increases by 1. So 1x minus 2. Okay? So let's talk a little bit about slope. Let me remind you guys that slope is the change in y over the change in x. You guys remember that? The slope is the change in y over the change in x. To write it a little simpler, some big math words here. They're not big words, but fancy math words. Delta. That means delta. So we say delta y over delta x. Delta means change. So the change in y over the change in x. All right, so in this case, this first case here, y is increasing by 1, isn't it? So that's a plus 1. And x is increasing by a plus 1. So your slope is simply 1 over 1 or 1. And that example goes with this guy over here. How do you feel about everything so far? All right. So do you guys think you can finish this worksheet?
Yeah.
All right, so we're going to finish this in class.
No.
And your homework is going to be 2.2 on Math Excel. Sorry, your Math Excel homework is 2.2. Finish the worksheet is classwork. Math Excel 2.2 is homework. Any questions? All right, great.